and memory stars used in TR news. This is a method used. And lattice simulation of phonon propagation, and Quaternion Field Theory, and biquaternion for 3+1 dimensional simulation, and Elman Recurrent Neural Network, and echo-state network, and 2+1D experiment and simulation. In conclusion, and outlook will give the last part. So, in application of non-directional testing, ultrasonic wave propagation in 3+1 dimensional system, including hysteresis effect, is important. In current 2+1 dimensional non-directional testing by ultrasonic waves, time reversal-based nonlinear elastic wave spectroscopy is applied. In the TR use, excitation symmetry analysis method is used, which is based on Quaternion algebra. We consider a lattice system in which Weyl fermions expressed by quaternions exist, and fixed point actions of phonons are derived, similar to that of gluons in quantum chromo dynamics. This is the experimental result of TR news using the Memotusa's reservoir, and this is the setup, experimental setup. The transducers and these are receivers, and the information are given in quaternion basis. Okay. Next slide, please. Oh, I cannot move the slide. Okay. Typical TR news experimental setup consists of a preamplifier and connected to a computer, and amplifier VBA 110, and a shear wave transducer technique sonics, and longitudinal wave transducers parametrics. And the perspective is to confirm the use of array of spintronics memotucers in self-calibrated setup for characterization of multiscale hysteretic properties in biomaterials such as skin, tooth, bone, or brain using nonlinear ultrasonic imaging. The memory star is the proposed is the fourth electronic circuit element after resistor, capacitor, and inductor. That was proposed by Leon Chua in 1971, and comprehensive review is in 5 on volatile memory star enigma solved in Applied Physics A in 6 years ago. This is the resistor, capacitor, inductor, and this is memory star. So next, please. We met Professor Leon Chua and his my colleagues, Sergio dos Santos, in 2014 at Prague in conference, NDT conference. Okay. And the application of machine learning technique to lattice simulation of wave propagation. Restricting the length of paths to be less than or equal to 8 lattice units, we consider A, 7 paths on a 2-dimensional plane, B, 13 paths on a 2-dimensional plane, combined with paths orthogonal to the plane, and C, 7 paths in a special 3D space, combined with paths which have hysteresis effects. In 1994, Stefan Adler proposed Quaternion Field Theory and discussed about optimization of the weight function. In lattice 2023, optimization QCD action via machine learning technique was proposed by Abbott et al. Yes. And fixed point action in quantum chromo dynamics. Dugrand et al. Proposed a fixed point action for SU3 lattice gauge theory. They considered Dirac fermion sitting on 3+1 dimensional lattices. When the path length is constrained to be less than or equal to 8 lattice units, there are 28 paths. We replaced Dirac fermions to Weyl fermions and ignore the path that passes through the periphery of a bracket twice, and consider 27 paths. Using singular value decomposition method, actions of phonons in 2+ dimensional were calculated. And in the case of 3+1 dimensional, so the A type consists of the two paths on the two-dimensional plane. B type is a three-dimensional space spanned by E1, E2, and E1 wedge product E2, which is also known to E1 and E2. And C type is consists of spanned by E1, E2, E3, and E0. And the E3, E0 is also known to E1, E2, and 3. And metric of E0, E0 is opposite to those of E1, E1, E2, E2, and E3, E3. This is the A-type path. There are 7, L12 to L18. These paths are reconsidered. And B-type, the simplest B-type is the L3. That is, it starts along E1 and go to E2, and then wedge product of E1 and E2, or wedge product of E2 and E1. We distinguish the two by circle that is going to up to the E1 wedge product E2, and this is E wedge product E2, E1. And there are more B-type, that is L4 to L13 is given here. And the third one is slide. Okay. L14, 15, 16, 17, and 27, 26, and 27. These are, so altogether, there are 13 B-type paths. So now comes the C-type. And there are 7 C-type paths. And there are these balls corresponds to the time shift occurs. That is, so for example, when the time shift occurs, the mixing of the, I assume that the mixing of all the paths appears when for example, here, all the paths contains the same position. But so at this point, I think I have we take the model that all mixing of the paths occurs. But for example, in the center, there are only four positions. So in this center, I think that the mixing of four paths occurs. Okay. And this is a fixed point action. There are 7, so this is the first 3, 1, 19, 20, and 25. And this X, Y, Z means that the path direction is X, then path direction Y, and path direction Z. And this is also in biquaternion basis. It can be X correspond to biquaternion 2, 3, Y direction is biquaternion 3, 1, and Z equal 1, 2, etc. And we have in biquaternion basis, we take the criterion that one of the two numbers connecting subsequent biquaternion must have the same one. So 1, 2 can connect to 2, 1, 2, 4, and etc. But for the L21 and 22, which comes next slide, here 1, 2, 2, minus 1, 2. There 1 is also connected, and also 2 is also connected. So there, this time directional path can, by Quaternion basis, it can be 1, 4 or 2, 4. So in this model, we took I distinguish 1, 4 and 2, 4 by taking 2, 4 as a L21 prime, and this is L22 prime. So altogether, we considered 9 paths in the first model. The next one. The main idea of our Quaternion field theory, the momentum space fixed point actions, we calculate the momentum space fixed point actions and choose the basis. And in the case of 3+1 dimensional, choose biquaternion basis, eigenvalue selection via singular value decomposition, and seek weight function of each biquaternion eigenstate contribution through machine learning. So we try Elman Neural Network and try also echo state network for optimizing the weight function. In standard echo state network, WRO, reservoir to output and input to output matrices are given, but we have only WRO of fixed point action. So we have, I will give next slide, please. So later. Okay, this is a echo state recurrent neural network solution. You consider the 9 input and 9 hidden layer and 6 output. And the one of great difference between the 2-dimensional simulation and 3-dimensional simulation is that in random walk, the return probability to the same position is dramatically reduced in 3D. In 2-dimensional, the random walk probably it's very probable that the random walk in 2 dimension returns back to the same position. But the 3 dimension, it is very few, only about 1/3. And changing the path through hysteresis occurs at t equal 4, 7, 8, 12, 15, and 16. And this is the result of the Elman Recurrent Neural Network method. And the input layer, hidden layer, and output layer indicated by IEL. And this is a state vector, TH, that is nonlinear function of W times X plus bias. And H state vector plus bias times matrix H, WHH. And this is F is the sigmoid function. And the YT is the output vector. This is also our sigmoid function given by this one. Using this model, we calculated the output at the t equal 4, 5, and 9, 10, 11, 12. Other parts are 0. And this blue one is without hysteresis effect, and red one is including the hysteresis effect. So the same thing we have done in echo state network. The left one side is the standard echo state network. That is, the WRO and WIO are given fixed. And the other is WOR, WIR, WRR are trained. But in our case, we only know the WRO. So WIO is made by multiplying WIR to WRO. And using this modified echo state network, we simulated the system's output with this is including hysteresis effect. So the echo state network's mechanism is written here. Input layer processes on the XT is in 4-dimensional real vector, and bias 7-dimensional real vector. And input to output weight matrix is 4 times 6 matrices. And reservoir to reservoir weight matrix is 7 times 7 matrix, real matrix. The loss function L is WRO times H minus Y star squared. And the state vector is the same as before, the sigmoid function of this one. This is time shift occurs. Yeah, it's here. And the output is given by also the sigmoid function of this one. The bias vector optimizes the vector enhances the optimization. This here, H is added by this one, and the loss function, derivative loss function, and the SRO derived by H, and so using that mechanism, we also modified the WRR, reservoir matrix, by changing this part. And using this method, we obtained this. Next slide, please.
Next slide support.
Next slide. Okay. So this is the result of after 10 steps. This is so orange is the t equal 8. It's state vector of type t equal 8. And this is the state vector at t equals 16. At this point, x are h is 0. So these are due to the bias. Then these are contribution bias. And but the other 4, 7, 8, 12, 15, these are around 0.5, but they oscillate in this 7 pass weight function. We want to calculate the weight function of these 7 pass. So this contribution oscillates. Oh. So next one, and then the bias vector is very has large standard deviation. So we performed, but of course one could deduce this by using large samples, but we performed, instead of increasing the samples, increase the cycles. The calculation, and we calculated 85,000 cycles. And and then we found very large difference from the 10 steps case. Okay. Okay. This is after 10 step, the y star t is some values assigned, not optimized, but test numbers. And the qualitative trend of weight at t are searched. And this is at t equal 8. This is t equal 16. But this is t equal 4 and 5. So except this 8 and 16, these values, this weight function is almost stable. You will see that in the next slide. I will show the, okay, 85,000 cycles after, and then 8 and 16, goes, these are both come from bias, and it goes higher. And but the other type part is almost same as before. And this is a state vector. The state vector comes, the 8 and 16 are concentrated on 1 or 0. And if I take the average, it goes to almost 0.5. And this is a t equal 4. This is 7. And this is 12. This is 15. So, okay. So the trend of weight function can be obtained by this method. Deviation, and this calculation was done using Mathematica, and deviation and the variance of state vector is changed slowly. So needed large cycle simulation for getting convergence, and training and validation gave similar results. Simulation yields YT for any t other than 4, 7, 8, 12, 15, 16. These data corresponds to the path whose initial path is on different two-dimensional planes. Using this WRO, we can calculate the proper y star t of t equal 4, 5, 9, 10, 11, 12, and compare with the Elman results. Okay. We perform training with 40 samples and validation with 10 samples. In the test run, variance of the deviation of validation and training are consistent. In controlling output data storing in Mathematica, every 100 cycles in 2000 cycles and every 5,000 cycles in 85,000 cycles, we check the trend of the convergence of steps. Except equal 8 and 16, we observe that the deviation is stable as the cycle increases. And to compare the simulation with the experiment, we did the 2+1 dimensional experiment using Nova University samples. This is the experimental setup, and the hysteresis effect is shown in this here. Okay. And next, this is the experimental setup. That is, there are transducers and here receivers, and information is given in the this, and if there cross of two waves received by these receivers, and this is in quaternion basis. There are 4 bases, E, A, B1, and B2, and these amplitude are shown here, experimental amplitude. And next slide. So TR news measurement details are given in the Dvorakova et al. In this paper. And cross-correlation function is given in this form, and covariance function, and the property of cross-correlation is given in this form. And we are trying to measure these numbers. And this is a experimental results. We consider the 64,000 epochs, and in the other half of the spectrum, there appear these two peak and one dip, or one peak and two dip. And this is AE, E, and this is A, and this next second slide shows the B1 and B2. This is B1, and this is B2. Then the time reversal mirror experiments, which was done by Professor Pink in France, also showed this kind of signal. And okay, so, and in linear approximation, the cross correlation can be calculated by mathematical, similar to the experimental one. The ratio of the dip, top and dip are different. So that comes from the nonlinearity. So we try to fix the edge, this ratio by including nonlinear effect to this equation. Okay. So Quaternion field theory and evaluation of weight function were discussed by Adler in 1994. And weight function can be calculated using machine learning method. In lattice QCD, it was presented in lattice 2023 by Abbott et al. In our equal state network method in 3+1 dimension using 7 biquaternions can be applied to 1+ dimensional using complex numbers and 2+1 dimensional using quaternions. And this was already published in Indian National Academy of Engineering last year. The Elman Recurrent Neural Network and Markov chain Monte Carlo was presented in this archive. So the future I will like to from output vector YT obtained after 85,000 cycles and WRO matrix, we can calculate Y star 9 optimal Y star 9, Y star 12, Y star 15, and compare with data of Elman recurrent neural network. And it is underway. And comparison with TR news experiments using NOVA University sample and 2+1 dimensional simulation using 13 paths is in progress. That is all. Thank you very much.